Today, we are diving into a fundamental concept in probability: mutually exclusive events. By the end of this lesson, you'll be able to define what it means for events to be disjoint and use mathematical notation to prove it. Let's start with a simple real-world scenario. Suppose you roll a die once. Can the result be both an even number and an odd number at the same time? Of course not. A single roll results in exactly one number. If it is even, it cannot be odd. In statistics, we call these types of events mutually exclusive. Another term you will hear often is disjoint. They mean exactly the same thing. The events cannot happen simultaneously. Two events are mutually exclusive if they have no outcomes in common. If event A happens, event B simply cannot happen at that exact same moment. To understand this mathematically, we need to introduce the concept of joint probability. Joint probability refers to the likelihood of the intersection of two events. We write this using the intersection symbol, which looks like an upside-down U. You can read this as the probability of A and B. When we visualize mutually exclusive events using a Venn diagram, the circles representing the events do not touch or overlap. There is no shared space between them. Because there is no overlap, the probability of both events occurring at the same time is exactly zero. This is your litmus test. If you are asked to justify why two events are disjoint, you must show that their joint probability is zero. Let's apply this to a concrete example using a standard deck of 52 cards. Suppose we define two events. Event A is selecting a king, and event B is selecting a queen. Ask yourself, is it possible to draw a single card that is both a king and a queen? No, a card has only one rank. Since a card cannot be both a king and a queen simultaneously, the joint probability is zero. Therefore, we can mathematically justify that drawing a king and drawing a queen are mutually exclusive events. Now, let's look at a case that is not mutually exclusive. Keep event A as selecting a king, but let's make event C selecting a heart. Can a card be both a king and a heart? Yes, the king of hearts exists. Since there is one card that fits both descriptions, the joint probability is 1 over 52. Because the joint probability is not zero, these events are not disjoint. They overlap at the king of hearts. In the AP statistics exam, you will often be asked to justify your answer. Simply saying they can't happen at the same time isn't enough for a formal mathematical justification. To justify formally, first identify event A and event B. Then, determine the joint probability P of A intersection B. Finally, check if that probability equals zero. Let's look at a data-based example. Imagine a survey of 100 students regarding their favorite subjects. Math has 40 students, science has 35, and history has 25. Importantly, each student chose only one subject. Our goal is to justify if choosing a student who likes math, let's call that M, and a student who likes history, H, are mutually exclusive. First, we look for students who are in both categories. According to our note, each student chose only one subject. Since no student likes both, the number of outcomes in the intersection is zero. Therefore, the joint probability is 0 over 100, which is 0. Because the joint probability P of M intersection H equals 0, the events likes math and likes history are mutually exclusive. To recap, mutually exclusive means disjoint. It means events cannot happen at once. The mathematical proof is showing that P of A intersection B equals 0. You've now met the objective of justifying mutually exclusive events using joint probability. Always remember, if there's no overlap, the probability is 0.